We have a little bit of hackathon discussion to do. Just as a reminder, this session is also still being recorded and live streamed to be distributed on YouTube later. I'm going to run through the normal preamble a little bit quickly, but one thing I do want to highlight again is we have our breakout sessions after lunch today, like we did yesterday, except this time we have working Zoom links. I sent out an email. You should all have an email in your inboxes now with abstracts and link details to these talks. I'm going to go ahead and put the links to all of these in the chat. One thing I do want to note, you'll see in the link in the chat that the link for preem session does require a passcode. This is also in the email that I sent out. You'll need to enter that passcode in order to join her session if you would like to attend. Any questions about the parallel sessions today, or concerns, or anything like that? Doesn't look like it. Again, we'll have this, we'll put this up on the screen when we go to lunch so that whenever you're finished grabbing your lunch, you can still get the links there, and we'll put them in the chat there as well. So again, like this morning, cut this down to 2 links now. If just remember to use the Slack workspace for hackathon teaming and discussion. I know a couple of groups have already gotten started talking about their projects on there. Like I mentioned yesterday, if you have created a private channel for your project, please do add me to it. I can't see your private channels in the Slack workspace. So if you add me to it, I can help kind of monitor what's going on over the weekend and help tailor our assistance to you as best we can. And that way, if you have any questions too, you can ask me directly in your group and I can see what you've been talking about before then. So please do add me. And if we need to add other people, I can then add them from there. If you have not added your description of your project to the teaming document, or if you have not updated the status of your group, please do go do that now. Let me grab these off the slide, because I know for a fact that this is the right link this time, and if it's not, I will have to go find a hat to eat. But yes, please do let me know in the chat if that's still the wrong link. It shouldn't be this time. So one thing I did want to do, I think, before we open up the floor for questions, since we're a little bit short on time today, I think what would probably be useful is if people who have things that they would like to discuss more in depth about their hackathon project, if you would please stick around at the end of the day, or at the very least come back at 6 for the Q&A session. We can spend a little bit of extra time at the end of the day today talking about that to kind of help prepare for tomorrow as we move into the hackathon portion of the workshop. We'll have a little bit of time here, but like I said, if you have questions that we don't have time to answer, please do come back at 6 with those. So I just wanted to review briefly, if you remember from James's discussion on Tuesday morning about the modeling process in general, there's a couple things to sort of think about as you start to formulate your project plan for over the weekend. I know a couple of the groups have already been doing this in the Slack a little bit. But if you remember, there was this kind of way that we think about talking about models, and that models have 4 elements. So they have objects, behaviors and interactions, initial and boundary conditions, and dynamics and events. And in the process of building a model, it's really important to kind of define these things as well as possible going in when you're doing your planning phase, so that you can start to think about how these things fit together before you actually start doing the code, particularly when you're in a short time limit like a 48-hour hackathon. And I'll have some questions in a minute about how to prompt you to think about that. So this is the exercise from Tuesday. We're not going to do this right now because we're a little short on time, but if you remember, we took 5 minutes during this talk to stop and think about your biological problem of interest with regard to these 4 categories of components of your simulation. And then ask yourself a few questions. So what are the specific hypotheses we're trying to test? How can they be measured? Or in this case, how can they be represented through the simulation? What are the key components you wish to model? And why does each of those components need to be included? That's a piece that often gets overlooked, but can sometimes help with scoping your project as far as like pulling things out that maybe aren't super necessary. Is these pieces are all here, but do we truly need every single one of them? And then also, what are which of these things do we need to include in our model and why are they necessary? We talked a little bit about the workflow of model development in proposing your project. You've already done a little bit of this with regard to the biological observations, because obviously the drive to simulate something is based off of something we've observed in nature usually, because we want to be able to test it. So you'll be doing kind of a shortened version of this over the weekend. Obviously, we don't have a ton of time to develop a super in-depth quantitative model. You'll probably be borrowing a mathematical model from an existing project in a lot of cases, and maybe not. Maybe this is something that you're trying to model for the first time. So maybe the mathematical model piece will be more important. But in a lot of cases, these pieces will be things that you'll probably grab, at least in some form or some preliminary form from other places and sort of put together for your initial prototype. But it is important to kind of think about this workflow as you're planning tonight and tomorrow morning about which of these steps is going to be most important to your project. James is adding some additional thoughts in the chat as we go too. So a couple of things, more specific things about scoping your project. First of all, from a management side, we talk a lot about, excuse me, let me grab a drink of water. I'm sorry, I've got a little bit of a dry throat today. We talk a lot about the process of scoping the actual model, but one thing that's also important to keep in mind, particularly for a 2-day hackathon, is scoping the management aspect of how your project is going to work logistically. Do keep in mind that you have 2 days to prototype your project, and I have prototype underlined here because that really should be the focus for a lot of groups. You're probably not going to have a fully functioning, perfectly ready to publish model by the end of the weekend. If you do, we probably need to look into hiring you. But for most people, in most cases, the goal here is to have a functioning prototype that you can build on after you leave the hackathon. I do want to note here that over the 2 days, you'll have roughly 10.5 hours of just free open work time. There will be, during the day when the hackathon is actually active, obviously you'll have the evening tonight and tomorrow to work with your group as well. But during the day, you'll only get about 10.5 hours of free work time. So you'll want to make sure over the course of the 2 days, we can talk about the schedule here in a minute if people have questions, but there are a couple of things that will happen during the day, little check-ins at lunch, and then presentations at the end of the day that will eat up a little bit of that time. So just to give you an idea of how much time you have for the next 2 days during the day, you've got about 10.5 hours to work with for actually getting your model built. Important questions to address logistically. So what is the end goal for the weekend? This is something you need to discuss with your whole group to make sure you're all kind of on the same page on each of these questions. If you find out at the end of the first day that a couple of people in the group weren't on the same page as you, that's pretty hard to come back from because you've done a whole day of work with people not having the same goals in mind. So it's important to ask these questions tonight before you get started on the hackathon. So what is the end goal for the weekend? What are we actually trying to produce? What is each person going to do? And then the follow-up to that is how will these pieces be combined? So you kind of need to ask those two questions in conjunction. What is each person doing? And what is the plan for actually bringing this stuff back together once the pieces are finished? Because you need to make sure that people are building the simulation in such a way that the pieces will interact together easily, or at least with minor modification when it comes time to reconstruct the simulation at the end of the hackathon. There's nothing worse than having 5 perfectly completed pieces of code that are just going to take 4 days to actually reintegrate at the end. So it's important to understand how those things are going to work and have some plan for making sure that people's components of the simulation sort of chain well with each other. Another important thing to start thinking about now is, what don't we know as a group? What do we still need to learn in order to implement this project? And when are we going to learn it? So that's something that's also important to be on the same page about. Do we need to sit down and have a research session for a couple of hours before we even get started? Or are there pieces of that that we can address as we get to them? Because you can potentially lose a lot of time up front if you want to spend, if you're trying to spend time learning everything you need to know to finish it. So some of the stuff you'll need to know at the beginning in order to get started, and some of the stuff you can kind of look into as you go along. So it's important to identify which things need to be learned now as a group and which things we can sort of outsource to the future for as we develop our project. James is saying we'll need to show them the daily schedule. I have that in here. I can show that in just a minute. My slides. Okay. And last thing is, another thing that's important to talk about is, what is the protocol when things don't work? So when your group members encounter issues, what is our plan for solving those issues? And which kind of issues require the whole group to stop and address them, or which ones can we let the individual group member hammer out? So again, you don't need to have, obviously you're not going to have like a super corporate structure for this weekend or things like that, but it is important to touch base before you get started, just to make sure that everybody's on the same page about how to address issues as they come up, so that you're not, freaking out sending emails around when those things come up. It's important to have a plan ahead of time. For project scoping, again, these questions that we kind of touched on a little bit. What are we trying to do? What questions is the model trying to answer? Hypotheses are we trying to test? If you're trying to build maybe like a test bed for future simulations, what is the function of that test bed? And what do we want the final result to look like? What would be a satisfactory end result at the end of the weekend? And is that satisfactory end result reasonable with the time we have? Another important question to ask as you move forward is, can the phenomenon we're modeling be broken down into component parts? It almost always can. So the follow-up questions there are, how long will each part take to model? And then, is one component enough for a 2-day project? So a lot of times you can break your project down into multiple pieces, and one piece is probably enough for a 48-hour hackathon. But then if you're going to do that, the important piece is, which piece is most foundational to the model? Which one do we need to build first, so that if we do get that done quicker than we thought, we can start building on top of that. So I think that's all I have in terms of just food for thought for moving forward. Like I said, we can spend a little bit more time at the end of the day today getting prepped for the hackathon for people who'd like to come talk. We don't have a whole lot of time to talk about teaming today, or in this session, because I do want to leave time for questions. But here is the main schedule for the hackathon. So like I said, you have about 10.5 hours of active work time. So tomorrow at between 10 and 11, we'll have some time for you to finish up organizing your teams, any last minute group changes or people joining groups will happen in that first hour. If you've already got your group, you're welcome to kind of go ahead and get started, but we will spend a little bit of time for the first 2 hours of the day with a little bit more guidance, helping groups set up their model and get the plans built. And you can be working in the meantime during that. From 1 to 1:30, we'll have a quick check-in in the main session. So we'll have breakout rooms for each group to work in during the hackathon, so that instructors can move between them and you're not talking over each other all day. But we'll have a quick check-in in the main session just to get a feel for where people are. And then we'll have 3.5 hours of work time in the afternoon, followed by half an hour of first day reports. And these reports are important because it gives us time to spend time in the evening getting feedback to people for the next day, which is what we'll do at the start of day 2 on Sunday. for the first half hour, and then you'll have a large work block to work on your models, again, followed by a quick check-in, another large work block, and then final reports and discussion kind of how things went, and what you'll need moving forward to continue building upon that model if you're interested in turning it into a full-blown publication, or just a model that you'd like to share on NanoHub. Or just a model that you'd like to have for personal use. Anything that you would like to continue developing after the hackathon, we are available to help with. So it looks like we've got about 3 minutes before lunch. I do want to get people off to lunch on time today because of our breakout sessions after lunch. So were there any questions about the hackathon or about teaming? Is there anything that you feel like we need to know about what's going on with your project or with your teaming progress so far?
What's the structure of reaching out for help during the work sessions during the hackathon? Like, can we come back to the main session to ask questions?
Sure.
Yes. Yeah. Yeah. We can have somebody sitting in the main session at all times so that we can relay questions to people as needed.
We'll try to have as many. Sundays tend to be hard, but we'll try to have as many volunteers as possible available to help out, join breakout rooms and troubleshoot with people.
Cool, thanks.
We'll also have everybody who is volunteering, we'll have them in the Slack with us as well. So that'll be a good place to kind of mitigate the breakout room barrier in Zoom. So you can shoot your question over to Slack and somebody can join and help if needed.
Maybe, Hayden, it's worth calling just the group leaders and asking them for just a 30-second or 60-second update of their status. Just go through the list.
Sure. So in that case, let me reshare our teaming document. All right, so we've got, so I guess I'll just go through these one by one. I don't know if everybody's here.
Well, it's okay if they're not here, it's all right, but let's go through just call them, see if people have anything to report.
Lorenzo, have you had anybody join your group, or how's your project going so far?
Not really, but said I'm happy also to support others to develop their own or from startup or to advise on different bits, those that I know, obviously.
Okay.
So it's not a big issue, so it's okay.
Great. So I think Max said he was traveling this morning. He's had a couple people interested, I think, but we'll have to check in with him later. James, how is your teaming going? I know you said you had still looking for a couple people earlier.
Yeah, hi. Yeah, we've still got the 3 listed at present. So yeah, probably still looking for 1 or 2 more maybe. I think especially one of our members has had technical problems with both NanoHub and the offline version of CompuCell this week. So yeah, I think it would definitely help to have 1 or 2 more people just in case there's issues on the weekend.
Okay. If that person that James is talking about is currently in the call, if they could come back at 6, maybe we can help them troubleshoot some of those issues, because we want to make sure you have a smooth experience this weekend. Or you can contact me through the Slack as well.
I don't think he is, but I think he has posted on Slack, so hopefully someone's been able to help him out.
Okay. Could you contact him directly and make sure that he reaches out to us, because sometimes the Slack doesn't get monitored as well as it could, and so if he comes at 6 o'clock, for example, we can troubleshoot with him.
Sure. Yeah, I'll send him a message and let him know.
Yeah, that'd be great. Karine?
Yeah, so we're currently with 3 people. So if anyone's still interested in joining, please send me an email. I think there's a description of the project below.
Mm-hmm. All right, Daniel. Is it Daniel or Mari as your first name?
Yeah, Daniel's my first name.
Okay.
Yeah.
How is
Yeah.
your project going?
Yeah, I don't have any member yet, but I can also work alone, try to work alone, and then seek help when I'm start somewhere else. But yeah, I'm still, open for if someone wants to join.
All right, and Liliana.
I also currently don't have any other team members, but I'm also happy to work on my project alone and also like be in a breakout room with other people who are working on their own simulations. Cause then maybe we can, even if we're not working on the same thing, we could like ask each other questions and help each other. So if anyone is interested in that and doesn't end up having teammates, let me know.
Right,
Yeah, I'm working on my project, so I'd be keen to just sit in a room with you.
Okay, sweet. Yeah,
Okay.
I'm also happy to have team members if anyone's interested in what I'm doing.
Izzy, was that you that was just speaking?
Yeah, that was me.
Sorry, my window is very small here.
I mean,
Okay.
we definitely want to organize. I mean, we don't want to dictate what people do. So if you tell us you want a breakout room called people working alone, we could certainly create one.
Yeah,
Cool.
I think that may actually not be a bad idea. And that way, if you guys have similar problems along the way, you can help each other solve them.
Yeah,
Okay.
definitely.
That's
But yeah, there still is some time today. And I think there's still a couple people who are interested in participating who aren't grouped. So
Again, being in a hackathon is a great way to learn. So I encourage everyone, even if you're a beginner, even if you don't have a project, it's a great way to learn.
So Bharat, I know you said you came in with a group, right?
Yeah, our team has basically 2 more, excluding me, but we're still looking for more people. I think the kind of work which you want to implement, it's going to probably take some time. And if you want to reach a stage which shows some things, probably having a team of 5 or 6 will be good. But yeah, we have 2 people already signed up, excluding me. Yeah, so we're a team of 3 as of now.
All right, Norma.
Yeah, I have one member, Julika. We both are from Purdue, and we are planning to move on some building in the university to work together and also to be connected in the Zoom call. And if someone is interested to join, it's very welcome. And yeah, we both have background in calcium signaling. We don't have too much experience in CompuCell3D. So if someone is really interested in that part, so it's really welcome.
Okay, great. So you're also doing zebrafish. I know the calcium signaling and the ray branching are different problems fundamentally, but Liliana and Norma, it might be good to stay at least marginally in touch during the hackathon because you are both working on the same biological domain in terms of zebrafish.
Yeah, true.
So you may have resources you can share to each other in that regard.
Okay, yeah, thank you.
So Darshan, how's it going? I think Darshan may be away. I know Nasheen is here. Nasheen, how's it going?
Yeah, sorry, good afternoon.
Mhm.
I don't have any team members till now, but I'm open to working alone, so I can learn more.
Okay, sounds good. So I think we're already 5 minutes.
It's also reasonable, if you're alone and you're not an experienced CompuCell person, I would encourage you to consider joining a team that is more established, that's doing something related to, but not identical to what you're doing, because it's a great way to learn.
Okay, and
not saying, I mean, by all means, work alone if you choose, but
yeah,
the
I
ability
was actually
with other team members, I think, is important. And so, if you find that there's for example, a talk on somebody's working on cell crawling or subcellular modeling or something else that could be of relevance to what you're doing, even if it's not exactly what you're doing, it's something to think about. I'm not saying this to you particularly, but to everybody as a sort of a principle of organization.
No, that sounds reasonable. I was actually thinking of by the end of the day, if I don't have anyone, I can join someone else and then maybe try to work in parallel with with the antimony model that I have.
Sure.
Can the hackathon questionnaire again. Is there anybody still who is thinking about joining the hackathon and might join one of these teams?
Yeah, so we still have 8 people on our list for looking for projects to join. If these 8 people are here and you're still looking,
Don't
Or
be
well-
shy. The fact somebody says they may not be experienced enough. I promise you that when you're doing these projects, just because you're not experienced, you could look things up on the internet. You could be reading Wikipedia. You could be designing the conceptual model. You could be drawing diagrams. You could be asking difficult questions. Just because you're not a CompuCell user doesn't mean that you can't contribute very valuably to a team.
yes, that's a good point. So there's a lot that goes into modeling other than just being able to write the code. So please don't be shy. If you'd like to participate in the hackathon, like James says, there are a lot of ways you can contribute. One thing I would ask here, because I want to let people get to lunch, is if you have your name on this looking for projects to join list and you are no longer intending to participate in the hackathon, please do remove your name for the list so that we know what we're working with. And if you are still looking for a group but your name is not here, please add it. And we can try to help suggest groups that you may be good for based on your background. We are almost 10 minutes over, so I think for those who are already participating in hackathon groups or are leading a project, if you can come back at 6 o'clock for Q&A, that would be very helpful. And if people who are still looking for groups could also come back, that'd be great. We know that's getting kind of late in the day for people, especially people in later time zones and hours. But if you are available, it would be super helpful just to get a deeper feel when we have a little bit more time to discuss. So I think if there's nothing else from James, we should probably let people go to lunch. Let me share this
That's
splash
fine.
slide.
Does the splash slide have the links for the sessions for the?
Yeah, I'm adding the passcode to preams.
Right.
And then we will be good to go.
Again, there's no project that's too small or too simple for a hackathon project. And everyone who has the time can contribute.
And guys, you can, for example, when I do my models, I start them, for example, 1 cell or 2 cells at most. And for example, a substrate, if it's 3D. So I try to do it as simple as I can, and I finish and I save, and I don't change it anymore. If I am improving, I build another one, and then I simply post the model I built, the simple one, for example, in my YouTube, or as I'm trying to do, showing you on Slack. So if you can develop a mechanism, a simple mechanism to model something, very, very simple. It's very nice. No, don't need to be complex. Don't need to be a research-like model.
Mm-hmm. Yeah, this is one of the things that I talked about a little bit yesterday. Is it's always easier to add complexity to a model than it is to have to scale it down once things go wrong. So it's perfectly fine to start simple and build up from there. Bharat asks, will be provided with the slides you just presented? Yes, I will upload them to the Google Drive and I'll email them out to you too. After we break for lunch here.
Okay, we have 4 great talks at 2:45. Everybody grab a quick bite to eat, and we'll see you back here in 35 minutes. Remember that Shane's talk will be in the main session, in this session, and the other 2 talks have their own Zoom links. We're going to have a great talk about cancer distribution. The cleft palate simulation is really an important simulation about toxicology that was done for the EPA. Very beautiful simulation, quite complex, but beautiful and predictive. Giuliano is going to be talking about NanoHub and how to upload simulations to NanoHub, and a little bit about how to do other things that you might want to do, how to distribute code and other things of this kind. And Priyam is going to give a great talk about using CompuCell dictionaries to do cell lineage tracking, and more about how to do plotting and data analysis. You know, these are all issues that people would like to hear. And it may be hard to pick one of them, but we'll have recordings of all 4 available afterwards. So we'll see you back in a little over half an hour then.
There are some people that want to see the adhesion model. So I don't know if I can show it here or we join the breakout room.
No, you can use the main if you want. Do people need the screen share? I'll tell you what, why don't you leave the screen? Why don't you take the screen share and work until 2:40, and then at 2:40 we'll put back the module information so that people have it.
Okay, sounds good.
Okay.
Sounds good. Okay, I'm gonna screen share now then.
I'm just gonna run and heat up some food. I'll be back in a couple minutes.
Okay. Okay.
Thank you.
Hi,
So
I'm here, but I'm just like running out of battery, so I will stay to the class because I was planning to charge it later.
okay, I can show to you guys later. Okay.
No. It's better actually now. I think it's gonna last like for some time. So
This is
you
also,
go ahead.
if your battery does die, this is still being streamed, so you can watch it later too.
Oh, great. Yes. So let's go. Thanks.
So if you guys didn't see, this is a model for cell migration without external force, external potential. And I simply use an internal field, and you can regulate shape and behavior of the cell, changing volume, changing energy. But the one I wanted to build to prove a point to a J is that you can model adhesion using another cell type, which is basically a point, to simulate adhesion point. So you can see that I can regulate the speed of the cell without changing the external potential. So there is external potential to the right here. And then, but what regulates the speed here is the adhesion itself, not the external potential. So I'm not changing any external potential parameter here. So basically, each red point is an adhesion cell, which I call the grip, and it is a very hard cell, so it has a very high lambda volume, and the lambda volume basically will regulate its decay time, its half-life. So if you decrease its lambda volume, basically it will disappear faster and the cell will move faster. And if you increase, like I'm doing here in the video, the cell will move slower because the adhesion has more half-life, more time of life. You can also regulate this interaction from the contact energies. So for example, when I change energy interaction between the cell and the adhesion cells, the grips, and when I change the energy between the cell and the medium, I am basically changing how hard is this grip. So this is basically the mechanism. the idea of this mechanism is to generalize to 3 dimensions. And the mechanism I use here is basically I loop over the boundary pixels and randomly generate, randomly create those grips. So you can see that the cell creates grips in all of its boundary, but the grip will only sustain if the grip is attached to, if the grip cell is attached to the substrate. So you
How
can
do you
make,
address the boundary pixels again? I didn't know you could do that.
yeah, so we actually used today this. So here in this the code,
Yeah.
basically what I do is I have to load zoom makes things difficult here to navigate, but
Yeah.
okay. Basically what I do, I have to include the boundary pixel tracker plugin. And then with this plugin loaded, I can call this pixel list get cell boundary pixel list. So these are all pixels in the boundary of the cell. And then for pixel in this pixel list, I can create a cell. So I am creating the grip in the coordinate of that pixel the boundary pixel with a certain probability. It's basically, this is all. And this has nothing to do with the model.
So they're just getting randomly generated on the boundary. And if the happen to be on the boundary that is adherent to the green substrate, then they will stick there. And the directionality comes from just randomly where along that bottom edge they appear. Is that, how does the directionality come? How does the system get polarized?
How the cell moves, you mean?
Yeah, that I guess is part of what I was wondering. So the cells are on the edge, they are moving around. I mean, they are appearing and disappearing randomly. Yeah.
The grips, you mean?
Yeah,
the
grips.
dots?
Yeah.
Yeah. So when this pixel back here, when the cell leaves it behind.
Yes.
Basically, because I have a very, very high contact energy between the medium and the grip disappear.
Ah, I see. I see.
So when it gets out of the cell, it disappears.
Oh, I see. That's color. Got it. Got it. Got it. So
Took
actually,
me a while to figure this out. Okay.
right. So I see. So that's how it. Okay, that's very clever.
And then I just have an external potential in the X direction here to make it move. And then I just by changing the properties of this grip cell and the contact energies, I can regulate how adhesive it is to the substrate.
So wait again. So the external potential is on the blue cell, or yeah?
On the blue cell, yes, on the blue cell.
Ah, I see. So I see. So I see. So the movement is not actually being so the grip cells are literally, as I had asked originally, determining stickiness to the substrate.
Yes.
Got it.
And they don't move. If I could run this video slower, you can see that they actually don't move. They only change when the cell creates another
new
one
in
the front, or when it leaves one behind that it disappears. So those pixels, they don't move with the cell. They stay still.
So how does it then so it has a certain adhesivity to the blue cell inside of which it is, correct?
Sorry?
The grip cells, the red cells, pixels, have some adhesivity to the green, and they have some adhesivity to the blue as well, right?
Yes, the green and to the blue, yes.
And the adhesivity to the green is much higher than to the blue.
Yes, actually, if you see here, this minus 100,000.
Oh wow!
This is a huge negative contact energy to make
Yeah.
the grip stick to the substrate as hard as I can.
So, but is the adhesivity to the blue also high, so that the stickiness of the grip cells actually impedes the movement of the blue cell?
Yeah, so these I regulate actually the thing is, you don't need to basically, the problem is you have many mechanisms here.
Yeah.
Why the grip impedes the cell moving forward, you can explain in two ways. First,
Yeah.
by having a high lambda volume,
Yeah.
and a high contact energy with the medium, basically the grip wants to be in contact with the blue cell.
Correct.
So when the cell tries to push, this pixel says, no, I want to stay in contact with you.
I see. They don't want to get repositioned, essentially, because of the
Yes.
high lambda.
Yes, exactly.
Right.
Exactly.
Right. So
But
it's
also,
the
if you
resistance to change that is keeping it stuck to the blue in some sense.
Yes, exactly. So I am referring as a half-life, in the sense that if it is in contact with medium, it has a chance to disappear because the lambda volume is high, but but the contact with medium is also very high.
Yeah.
They will fight, and
It'll be penalized for that.
Exactly.
Cool.
So there is a
Great.
probability of creating and a probability of to disappear.
Right. Yeah.
Sorry,
Do you
Ajay.
have this on your website, please?
Sorry?
Do you have this linked on your website or somewhere?
No, I just made it during the last lecture. So I didn't
You're
upload
very
it yet.
fast, Pedro, for me, but I would like to analyze this and do the program and everything in my on my own time. If you can make it available or send it to me or whatever.
So
I'll
this is
appreciate it, Pedro, but you don't have to do it.
this is the simulation running, in case you are wondering. No, he just made a movie. He didn't make it.
No, I believe you. No, Pedro, I'm not critical like that. I'm just here to learn.
Yes.
And I'm a slow learner by definition, by declaration.
That's okay. I will send both simulation, this one and with the internal field
The
to make
codes
the
and
cell move.
everything, the Python, all this gymnastics.
So I have another question about this other simulation that you were showing with the rack and roll.
Okay.
So there are many sort of models that have been made with rack and roll. Actually, I'm more familiar with some that were made on Morpheus. So one of the things I was wondering about is, does it care about the environment, that is about the existence or not of ECM, or can it be made to be paying attention to that? Because in some sense you have one of the things, another model that we're trying to work on is to see to what degree you can get the self-organization of shape of a cell based on whether it is in contact with a substrate that it wants to migrate on, whether it's associated with an adjacent cell to which it is adherent, and whether it is not attached to anything. So the essential thing that I was trying to figure out how to do in CompuCell or in actually Morpheus is that rack and row can do two sort of extreme things. On the one hand, it can self-organize into a polarized behavior that can determine migratory behavior.
Yes.
On the other hand, if it is not in contact with ECM, it will promote contraction of the cell or the membrane. And so if you have some way of having rack and row influencing the behavior of the membrane, and you have cells in a row placed on a substrate, they will automatically, in principle, I'm trying to explore whether they will self-organize to form epithelial rosettes, whether they will start moving on the substrate in the formation of self-organized rosettes, because on the bottom they will be attached to a substrate that will allow the rack and row to organize in a way that determines migration. Side to side, they will just stick to each other. On the top, there will be rack and row will not interact with basement membrane. So it should promote contraction and it should constrict automatically. So I'm just trying to see through the dynamics of rack and row and cell-cell adhesion, if you can get all these emergent polarization and morphogenesis of cells. You see what I'm saying? It's a little bit complex.
Yes. So first, in this 2D simulation, there is no way you can model the influence of the substrate in the cell shape, because you don't have substrate. But in a 3D simulation, yes, you can change cell shape by changing contact energy with a substrate. You can change cell shape by making that cell moving, for example, between other cells that are for example, that are holding position in space, or with other motile cells side by side, or in the front, in the back, etc. You can model all those processes. So, for example,
so to some degree, in even the other model with the grip cells, the two parts of the three things that I was hoping to achieve are actually already there, because you have a green substrate at the bottom, and instead of a single cell, if you had multiple cells that could be in contact with each other, and let's say you had multiple blue cells and they were able to stick to each other, then they will move together. And
yes, they would stick. Yes.
Yeah. So because they will stick to each other rather than being the relatively flat blue cell that you have, they might become a little bit more columnar. At the same time, the bottom might spread out because, well, the blue is also, I assume in this simulation, adherent to the green, and then the red cells also are adherent to the green. So the only thing that I don't know how to simulate as an emergent property without sort of artificially making things contract with FPP links or something, is how to incorporate this notion that when rack and row are not in contact with the ECM, they will determine contractility of the cell. You see what I'm saying?
This I don't know how to do.
Yeah.
This
But
is
it's very nice. What is nice is its simplicity in some ways.
Yes, exactly. Actually, those type of very extreme behaviors, for example, the same thing in one situation behaves completely different than another situation. This can only be true in biology because of the complexity of biology. because you have many other reactions taking place, because the shape of the cell also affects how the fields will distribute inside. So everything interconnects to produce those different behaviors. And the problem, which can be a problem or not, is that in CompuCell you have simplicity. And some simplicity can prevent you from building those very general properties that, for example, I take this cell here, for example, and then I simply change to three-dimensional, and then it starts to do another thing that I wanted. So this is very, I was trying to do this once, but actually you have to change so many parameters that it's humanly very difficult. It takes a lot of time to find the right parameters to change behaviors in different situations. So
see, I have
probably
an idea with this particular model that you have. One way in which it could be extended in along the direction that I am thinking about. So let's say you already make these what you call grip cells appear randomly on the
boundary
perimeter, on the boundary. What if you added to that the possibility that within a certain range, each red cell makes an FTP link with its neighboring red cell?
Ooh,
yeah,
that's a very nice idea.
Yes, and now for the cells that are in attachment to the substrate, they will resist being pulled together and it will spread out in a particular way. But the part of the cell that is free, the links will pull the things together. And this will create a little bit like what I'm trying to tell about the polarization of rack and roll. It's not rack and roll here, it's a different way of doing it. But that's that could be kind of cool, don't you think?
Yes, it is very interesting idea. I didn't think about that.
Yeah, and it automatically creates, it's a little bit like creating a vertex model, you know.
Yes.
It's like combining some dynamic features of a vertex model with actually, maybe we can try that. If you can send me this version of your model, or you want to try what I am suggesting and explore it, that would be kind of fun to pursue a little bit, because that kind might result in some kind of interesting dynamics. So in fact, you could create that boundary thing. You don't need to have the thing where it falls outside and disappears. You can just have them remaining within the perimeter, attached to each other. And so each one can only make contact with two others, which are, or even if you start them out that way, I don't know. It's a slightly different model, but it's to explore a slightly different aspect of this.
Yes, I think it will take a while to reach this idea of yours.
Yeah.
But it's certainly an extremely interesting idea, because you have a compartment that exists in both cells in contact.
Yes.
And they make the link, not the cells.
Yes.
This is very interesting.